It was a horrible idea.
It's good you still have two hands. Hi, and welcome to the Hackaday podcast. I'm Elliot Williams, editor-in-chief of Hackaday.
And I'm Dan Maloney, staff writer at Hackaday.com and community engineer at Hackaday.io.
This is episode 161. Today we'll be talking laser lithography, Centurion hard drives, mad BGA soldering, and shortwave subversion. And this week we've got tons of cool hacker news for you. So why don't you start off, Dan?
Someone is doing the important work and managed to find an Easter egg in Windows, not Windows 4 or Windows 3, but all the way back, Windows 1.0, 37 years after it was first published. I'm not sure exactly what the key to opening up the Easter egg is, but it opens up a credits screen for people who wrote whatever that part of the package was. It's nice to see that even way back when, people were kind of sending up these little semaphores of, hey, I was here and I suffered needlessly for this feature or that button or widget or whatever.
I'm reading the article right now. It's the hidden dialogue was placed in an encrypted form at the end of the smiley bitmap file included with the operating system. That is pretty crazy.
That's pretty dug down deep, you know?
That's pretty sneaky. Yeah, well, that's how you get an Easter egg that doesn't get discovered for nearly 40 years, I guess. Well, my favorite news story of the week was one we ran. Satellite snoopers pick up surprising TV broadcast. This was a couple Twitter posts, two radio/satellite listeners working together, posting up on Twitter, Derek, SGC, and Scott Tilley. The funny thing here, though, is that they were listening to a Russian satellite. I think it's a Russian military satellite, and ended up hearing a Turkmenistan civilian TV broadcast. And what's happening is the angles work out right, that this TV broadcast that's supposed to, kind of spread out horizontally to blanket a town is then going over the horizon, hitting the satellite every once in a while. It's in just the right band that the satellite apparently picks it up and then retransmits it. Is that what's going on here?
I think that's what's happening there. And I have to say, to some degree, I was a little disappointed that's what it was doing. At first, I thought it was the TV signal was literally bouncing off the satellite.
Yeah.
Physically bouncing off of it, like you can do the airplane scatter and all that stuff. And I thought this would be really cool. If you could scatter, bounce, or whatever off of satellites in orbit, you've got some cred with me.
Yeah,
this
right?
is still pretty cool. The fact that they managed to hit a transponder that just happened to be on the same frequency and bring this signal halfway across the globe. I thought that was pretty cool. I mean, it's barely a signal from the look of the screenshots. It's pretty hard to see, but still, it's really cool that they were able to pull this off.
Yeah, with an SDR and the right antenna and I guess the right amplifier too. They have a nice custom-made LNA low noise amplifier to run it, but still, it's not much gear. This makes me think that if the same satellite is accidentally picking up and retransmitting TV data, how easy are these things to jam? Couldn't you just send up your own whatever at it? Why am I not using this satellite to my own advantage?
I remember writing an article on this. There's a presentation that a fellow did about exactly that, using other people's satellites without their consent or knowledge. Well, I guess probably their knowledge, but without their consent to relay your own signals and satellite piracy, because they basically put these things up there thinking, who's ever going to do anything with, sure, we'll put an open transponder on there. Nobody will ever do anything like that. And all of a sudden here, 10 years later, 20 years later, yeah, we can actually bounce our own signals through somebody else's satellites without having to go through the trouble of putting up our own.
I don't know. It's insane that it's television broadcast. It's terrestrial TV, but it's insane that it's happening at all.
True.
And last but not least, in the news of the weird, welcome to the future where your microwave thinks it's a steam oven. This was another Hackaday story about how AEG pushed out a firmware update to its Internet of Things microwaves, but it pushed out the firmware update for a steam oven instead of a microwave. and it bricked them all. And the worst about it is that it looks like it's going to require physical presence to unbrick the microwave ovens. This is one of those things where if you're going to have IoT devices, you absolutely need them to be remote upgradable, because if it's got a flaw and it's exploitable, you want to be able to clean that up for your customers. But man, if someone else takes the system over, or if you just screw up, the liability is huge. This is the double-edged sword that is internet-connected microwave ovens. I have no idea why a microwave needs an internet connection.
Yeah, and I've always sort of looked a little askance at the subtleties of microwave cookery. Like, oh well, a couple. What do you have to control? It's not like you're controlling the frequency of their microwaves. It's not like you're controlling, their intensity or anything like that. It's on or off. All you got is duty cycle. Is it really going to make that much difference to the burrito or to the lean cuisine or whatever? I think it's splitting hairs and trying to sell something to somebody.
Jenny, who wrote this up, suggested that the real reason the microwave oven is connected to the internet, of course, is that it's reporting your behaviors back home and they're selling it. So if that's the case, then they deserve it. Frankly, AEG deserves the customer nightmare that they're going to get for this one, if that's what these things are doing.
Yeah, make me the product, will you?
This is a journey into sound. What's that sound?
What's that sound?
And that round of Schadenfreude brings us up to our What's That Sound drawing. Last week, we had a very popular entry. Tom named this within 2 notes and laughed at me and said this was the easiest one ever.
I don't have it. Nope, I don't have it.
What? Oh, congratulations. No. You are the winner this week. Dan Maloney, you have not seen the TV show The IT Crowd.
I have not, no.
I
watched Silicon Valley.
Are missing out on the best British sitcom of the last 20 years. And you are the luckiest man alive. You've got the next 2 weeks of work set out for you. You start at the beginning and work your way through. It is so fantastic.
Wait a second. Did my boss just tell me to watch TV for 2 weeks?
What?
I'm on it. Thanks,
you
man.
have won, sir. Yeah, exactly.
Okay, I'll report back in 2 weeks.
This was a fantastically popular one. Let's see. This was actually suggested by my wife, and I said this on the show last time, and I was like, I think it's too easy. And she's like, do it. They'll have fun. We got 96 answers, of which 95 were correct. 1 was a duplicate. Nice try, Matt. Essentially, all of them were right, which is fantastic. I always learn something by reading the answers. Like, I didn't know who wrote the theme music for the IT Crowd until reading your answers, and it turns out to be Neil Hannon, so I had to Google him. But the number of people who entered either in their nickname or in the comments, what is it? I can't remember the number. How did you all remember the number, you crazy people?
011899988119725.
You people are fantastic. Again, I'm drawing my wife's pair of 100-sided dice. So we've got a 20 and a 6. That's 26. And the winner is Phil. Congratulations. Theme tune from the IT Crowd. I'll get in touch with you, Phil, real quick, and we'll get a t-shirt out to you shortly. Everyone else listen in next week, and we'll do this again. All right, it's time for some hacks, and I would like to start off with Zachary Tong of the Breaking Taps YouTube channel's Old Printer Becomes Direct Laser Lithography Machine, which is in principle kind of pretty easy. You just shine a laser onto a silicon wafer that's covered with a photoresist, and it's like making a PCB where the laser makes the photoresist stick, it doesn't wash away, and then you etch it. Right? Except this is that at the kind of 1, 2, 3 micron scale. And that means you have to know what you're doing with lasers, and the machine has to be stable enough to not wiggle around in the breeze. And you have to basically dot all of the I's and cross all the T's. And that's what this video is about. Like, he shows us the results, and the results are pretty good. They're, 80% of the way there already. But then he walks you through how the whole machine works. And if you've ever wanted to play around kind of seriously with lasers, this is great because it steps you through all the important bits. He kind of has a nice handmade, I guess it's CNC made optical bench, which is kind of the optical equivalent of a breadboard, he calls it. He starts off with a lousy diode laser and then spatial filters it, which is basically you focus the laser on a super small pinhole so that the beam that makes it through is the good center part, and it kind of filters out the crappy elliptical stuff out at the sides of it. And then another lens to collimate this, and then he bounces it. He runs it through it turns out they're just the regular kind of light show galvos that you can buy these days for $100 on eBay. He picked them out of a 3D printer, a resin printer, but it turns out they're just kind of the commodity galvos that you'd pick up somewhere else. And this ends up being one of the weak points in the device. He mentions that later. But then it goes through a scan and tube setup, which is a pair of lenses that kind of make almost a telescope to take the beam from the galvos and put it into the eyepiece of a microscope, which then focuses it down small enough that it can expose his substrate. A crazy system, but it's full of all of these kind of building blocks for any serious laser work. So just for that alone, it's totally worth your time.
Yeah, for as non-optimized as this whole thing is, the results he gets out of it are pretty impressive. It's just parts that he had lying around for the most part. Like you said, the galvos are just whatever. I've got a couple of lenses here. I'll throw them on the optical bench. Oh, it's not, I've got it sitting up high when it should be down low. 3D printed parts all over the place. But still, it got pretty darn close to getting really good results. And like you said, it's nowhere near ready to just sit down and use it. It has to be tweaked every time he does anything with it. And, that's obviously a problem going forward. But to get a real result out of it, as janky as it is out of the gate, makes me think, wow, when this thing really does get optimized, we're going to see some pretty cool stuff.
For sure. And part of his ability to get good results out of a janky setup is that he's able to look at the results really well. Like, he's got a good microscope so he can see what he's getting out of this. And then when he breaks out his homemade atomic force microscope to do really serious analysis of like how deep the trenches are and how good the focus is and things like that, then that's when it's getting really serious. But if you want to get your traces down in this kind of single digit, low 1, 2, 3 micron level, you have to start caring about all this little stuff, right? It's great that he already built the measurement gear that he needed to make this thing work. And I think there's some kind of growing synergy going on over there in his shop, where once you have the measurement stuff, then you can start building the stuff that you need to be that accurate, and you can start working on that. But like Dan said, this is prototype number 1. It's got wobbly lines and crappy galvos, and, he played around with using different resist materials, and, he'll probably replace the 3D printed plastic with metal because it doesn't shrink and melt and warp, and he'll get himself there. But he's got an amazing first try here. And I don't know, I played around with the idea of making myself a direct laser PCB resist exposer. And so this is like, 100 times wider lines than what he's dealing with. And even that's a little bit challenging. And I've wanted to do that for, probably 10 years now and never gotten around to it because I'm kind of a toner transfer PCB guy. But I'll throw some links into the show notes of 2 of my favorite projects that people on Hackaday have done with direct laser PCB exposers. This is that same project, but like to the nth degree, and involving some serious optics and Really, really cool.
Yeah, and the interesting thing to me is this is not Zach's background at all. His education, he's a neurobiologist by training, and I think that's what his day job is now. So he's coming at this just completely hobby level, things that interest him. And to me, that's the interesting thing, that you don't necessarily need to be quote unquote trained to get things like this done. You just need to be curious and apply yourself a little bit, and you can do these things, which, let's not make any mistake about it. He's trying to make MEMS machines in his garage. So that's a big deal. As if making an integrated circuit in your garage isn't enough, let's throw on another layer of complexity and make MEMS devices.
I was totally going to ask you, didn't you have Zachary Tong on the Hack Chat a while ago?
Yes. Last year, maybe? Yeah, I think it was last year.
I missed that one. I'm going to have to go check that out, though.
My first pick is minicomputer restoration hanging in the balance. This is David Lovett, who's also known as Usagi Electric. David's got a lot of cool stuff going on. In a lot of ways, when I watch his videos, he's got a lot of eclectic interests. And I see his setup and I think, wow, David's got my life. He's got this awesome barn at the end of a long dirt road somewhere in Texas, and he's got it full of all these really cool Japanese cars that he restores, and he's got a Bridgeport mill and a big old lathe and all kinds of tools and everything like that. And I think, wow, adopt me, David, right? But one of the things that he latched onto some time ago is this bizarre old, what are you going to call it, mainframe mini computer made by a company called Centurion. 80s, I'm going to guess. I can't remember the exact date. I know he found some date codes and stuff like that when he first picked this thing up off of eBay or wherever he got it. And it was a wreck. It was filthy. It was falling apart. It was just a disaster. A couple of big cabinets, rack mount cabinets that were partially filled with chassis and cards and stuff like that. A couple of old terminals, which cleaned up real nice. Those things look sharp, I think. They've kind of got a Lear Siegler look to them. Monochrome monitor, keyboard, this very distinctive blue color that is picked up in accents throughout the whole thing. And then there's the obligatory walnut trim pieces too. I mean, somebody spent a lot of money on this thing back in the day, and he got it for a song because it was so obsolete and so old. He spent the last, I can't even remember when he first showed this on the channel. Periodically he works on it and gets and makes some progress and trying to get this thing back to its former glory. Doesn't look like it's gonna happen though. With the latest discovery, he dug into the hard drive on this thing, which is ludicrous scale. It's got platters the size of LP records, and he opened that thing up and found this big skid mark going all around the circumference of the disk, showing where there was a head crash. That's the disk where the operating system of this beast lived. He did a little forensics on it to kind of figure out, well, what happened here. And it looks like the air filters were not ever serviced on this thing, and that led to a cascade of failures that caused the head to crash and showed us the landing marks of the head as the disc turned underneath it. So maybe not that he'll ever be able to get this thing back in action. The interesting thing was he actually managed to find someone, or was a previous employee of this company, Centurion, and had a whole bunch of undocumented insider information that he could provide, including some software that was written to actually do testing on this originally, plus hardware. And he's like, oh, well, let me look through my bin of stuff and come up with this thing that was built 30, 40 years ago or more that may actually be able to help him get this thing up and running. It's touchy. I don't know if it'll actually happen. What I was curious about, though, or what I found curious, was in the comments, some people were saying, hey, just pull those platters off. The density of hard drives from that period, the data density means, you don't really have to be super, super precise reading those things. And chances are that skid mark didn't erase too much. You might be able to get a lot of information off the disk.
I was going to say you could just throw it on a record player and get a cassette read head in your hand and just kind of track it slowly across.
It's about that size, yeah.
Those of you listening at home who have not seen this video, Dan mentioned that maybe the head crashed because it needed its air filter changed. There's a picture of him going into this thing, and you lift up the hood on this thing like it's a car. And to service it, it has one of those little proppy up things, like you prop up the hood of your car. This is inside a hard drive, people. You lift up the hood, you like prop it with that little stick, and he pulls out the air filter. And it's in a box, like it's the air filter in your car, and you're supposed to take this out and service it, of course, because, you know, back in the day. And so you take it out, you service the air filter, you put it down, you pull the little stick, you close the hood, fresh tank of gas in there, and you drive this hard drive off, I guess. Like, I can't imagine, but like the belts on this thing, the capacitors on this thing, it looks like it's a hot rod much more than it looks like it's a, you know, tiny little Seagate hard drive.
It's obvious that it comes from a different time. Computers were, I mean, this was sort of in that interface years between PCs and the democratization of computing and all that stuff. And just, you know, just before this was the, you know, white coats in the, you know, in the dedicated rooms and the, you know, refrigerator sized computers, that kind of stuff. This is the size of maybe a refrigerator or two, actually, a dorm refrigerator. But still, you know, good on David for taking this obscure bit of computer history and trying to make it live again. And again, he's coming from someplace that's completely different. His stock and trade, quote unquote, on YouTube is making vacuum tube computers and doing vacuum tube circuits. Not a tube to be found in this computer. So he manages to stretch himself well beyond his comfort zone to do things like this. Always enjoyable to see one of his videos come out and see where he's going. Is it going to be tubes? Is it going to be Centurion? Is he just going to be driving around in one of his cool old Isuzus or what? Dave's a lot of fun.
Boy, and if you want to talk about insane attempts to reverse engineer / repair old technology, this one takes it forward about 20 years. Dmitry Grinberg, hacker challenges memory stick to a fight and wins. This is the insane story of him reversing Sony's memory sticks. And this was Sony's completely proprietary, basically SD card equivalent. It spoke a language only known to Sony. Well, I mean, Sony's the king of proprietary media, right? This was only ever used by Sony products and sold at incredible markup if you had to buy one. And so this is Dmitry trying to take it out on them, even though, you know, it's 20 years too late. If you haven't read any of Dmitry's projects before, you might not know that he is entirely relentless and will chase down whatever hardware it is necessary to get it completely reverse engineered. And that is also the case with the Sony memory stick. But he's also really funny in writing up his comments and all of the landmines that Sony leave for him along the way. There are things like it's got a clock and data line set up, and it changes the data after the clock changes at some points in time, so that you have to have read it in by the time you get the last clock signal. There are parts of the protocol that change polarity depending on where they are in the instructions. There's normally, like, if you're talking to a device and it wants to say it's ready, it'll raise a line, you know, say it's an I'm ready line. This one pulses the I'm ready line with either hex AA or 5-5 pattern, right? Just up, down, up, down. This is the strangest protocol you've ever seen, and it's fantastic that he's able to get this far into it, and he's actually managed to write himself a driver so that he can read to and write from Sony memory sticks. And this hack, if this were 30 years ago would have broken their monopoly on the memory stick devices, and people using Sony devices would have been dancing in the streets as they were able to buy cheaper memory devices for their like old camcorders or portable music players or whatever else we put these memory sticks in. It's a really cool write-up and one of these like insanely detailed reverse engineering stories, but there's probably something for you to learn here if you're interested in kind of taking the logic analyzer out, plugging it up to something and seeing how it works.
I love the disclaimer. What he said? Something about it was obtained by participating in demonic rituals. It might kill your cat or break your car. But anyways, this picture shows these memory sticks of this, which just look like an SD card that's been stretched out somehow. It's kind of bizarre. They show a couple of things from the Clie gear line, which I vaguely remember. Like one obviously has a camera on it. One has a GPS antenna, but I don't remember where these things showed up. I wasn't in the Sony ecosystem very much, so I find it odd and unusual that these things exist. I do appreciate the effort for going back and digging through these and digging through the protocols and trying to make these things bend to his whim, 30 years later.
Yeah, the commenters on this one mentioned that, and they're like, copy this website now before Sony comes in and gives you the takedown on it. I wouldn't be entirely surprised if they tried, but I don't think they have a legal foot to stand on.
Okay, my next pick is Careful Cuts Let Logger Last a Year on a Coin Cell. The title means a little something different to me. When I saw logger, I think, because I live in Idaho, I think of guys who cut down trees. But no, this is a data logger. It's something that's aiming for an unusual environment. It's submersible data gathering that is going to be problematic to change batteries. This is by the Cave Pearl project, which is doing submersible environmental monitoring, at least in this device. And the idea here is to, first of all, be cheap. Second of all, last a long time without maintenance and in environments that are not necessarily going to be accessible, submersible. So you'd have to, either go in a boat or do some scuba diving to retrieve these things. CoinCell was the obvious choice for powering this. Maybe not actually the obvious choice because they're not exactly the picture of energy density, but they are readily available, cheap, and reliable up to a point, up until they run out of juice. Squeezing absolutely every bit of energy out of the coin cell for this project was the goal. It involved a lot of board level hacks and hardware hacks, like clipping leads on voltage regulators and making sure that unnecessary components were not included. The build is based on a Pro Mini, and being able to operate that for a year on a coin cell is pretty darn impressive.
Yeah, I love this one because the chip itself has such a super low sleep draw. Like these things, if you read on the spec sheet, the Atmel chip involved will go into deep sleep at like 1 microamp. And if you've ever tried to get any device with one of these actually built into it to draw as low as 1 microamp, you'll discover that it's basically impossible. And so you start at the top, right? You're like, well, that LED that's blinking, I probably don't need to burn those 20 milliamps. And so you clip that off, right? And then he keeps going through and through and through. But it's amazing how far along he gets here. Like when you're talking about getting the whole chip's draw down to around 1 microamp, you start to worry about the reverse leakage current across a Schottky protection diode. Clip, out that goes. You start to worry about tiny amounts of current being conducted here or there, right? Like the regulator, that has to go because that's got more standby current by a lot. Tantalum capacitor, ooh, maybe too leaky. Clip. It's really awesome to see because it really is kind of going through all of the like random, vampire current draws that all of the parts that are on this board has. And he ends up with just the absolute basics, right? Like he's got no reverse battery protection. It's only going to run on a coin cell, so he doesn't need to worry about the thing overvolting. So out goes the regulator. It's really just what is necessary to get the job done. And so when you're doing really ultra low power stuff, thinking about all of these is really useful. And this is a good tour of all of the stops you should check along the way.
Reading further into it, you realize that this is a device that needs to be made in bulk at an instructional situation. They're going to put 15 or 20 of these together, and students are going to do that. So, not only all of that optimization for battery life and all that, but it's something that's got to be put together by people who maybe are not completely fluent with this kind of stuff. So, there's a lot to this one that's really interesting. And I'd like to dig into it a little deeper, maybe.
My next hack is Sprite TM in heroic efforts give smallest ARM MCU a breakout and open debugger. We covered this microcontroller a couple weeks ago, and I know I talked about it here on the podcast because it made me think that I really need to try my hand at some BGA circuit layouts, but probably not for one as small as this chip is. And it actually prompted me to write a newsletter and post with the title, How Small is Too Small, where I basically concluded that this microcontroller was too darn small. And so here goes Sprite to show me up. Thanks a lot, man. He, makes his own breakout board for this thing, which is fantastic, to at least give me a little cover on my feeling that this was finally the ball grid array that was too small. He actually has real trouble getting the internal balls out, which was what I was worried about, because you'd have to go down and under. But because this is Sprite, he's got a super clever trick, which is the following. The 4 pins that are on the inside of the ball grid array, he actually just connects them to the pins that are outside of them. So instead of trying to snake them through the holes between the balls, he just actually runs it straight through. And this dirty hack works because the pins on the outside are GPIO pins. And so when you boot the chip up, they're not pulling up or pulling down, and you can talk directly through them to the pins on the inside. And then once those are all configured and everything's up and running, you can then use the pins on the outside as, for their intended purposes, which is a super clever hack and lets him make his own PCB breakout board for this thing, which he then demonstrates an air soldering on. That's pretty awesome. He then goes to adapt the kind of open source ARM debugging and programming toolchain to work for this, which basically means writing code for OpenOCD to be able to talk to the flash ROM that's on the chip. So he's able to actually program the things. He makes use of a bunch of other people's work and also the SDK that the company provides for this chip to figure out like some of the magic values and stuff to make it work. But basically, it's a case of get your favorite ARM compiler and use GDB and OpenOCD with his one description file, and you can actually program these things with a full open source toolchain. That's really cool. That's also in his blog. You should check that out. And then finally, he decided to hand airwire one of these things. And over like a 2-hour long live stream, sits there with the magnet wire under a microscope, trying to tack it on to these 16 tiny little balls that are separated from each other by like 1/10 of a millimeter or something. It is shaky hands extreme, but like he says in the live stream, doing it under a microscope, it just gives you a lot better hand-eye coordination and makes it possible for you to do this sort of thing. Still, it's a phenomenal feat. And if you want to learn about doing this kind of, I would say, absolutely extreme, if not extremely unnecessary soldering tricks like he's doing here, it's a great video to watch because there's a whole bunch of tips and tricks the whole way along. It takes him an hour and a half to solder 16 wires. So, this is not easy. In fact, it's a miracle that he can pull this off at all. But it is totally also the case that you can hand wire a chip that when it's flipped upside down is significantly smaller than the lands on one of those little standard perf boards, right? Like the little pads on a perf board dwarf this chip in question. And he ends up hooking it up to a whole bunch of 0603 LEDs and programming the thing, blinking them all, and the chip almost disappears at that point in the middle.
We're actually at the point where watching someone solder for 2 hours is probably more entertaining than just about anything else that's available on YouTube or on TV or whatever. And it is. It's like watching some sort of extreme sport, but in a tiny little environment. And I do agree with his assessment. Like once you're under the microscope like that, it's like your attention kind of changes. The scale of your thinking changes. You're able to do these things that you couldn't possibly do in the macro world if you didn't have that. Your brain is getting stimulated in a different way or something. I don't understand it, but it works, and your hand-eye coordination changes completely, as long as you haven't had a lot of caffeine, because that's certainly going to ruin the day. The other thing I think of when I'm looking at this is that we had Matt Venn on for Hack Chat last week. His ASIC that he designed was being packaged in a WCSP, if I'm not mistaken. My question at the time was, well, how do you use it once it's packaged and given to you? How do you use it? And I'm like, well, okay, this is how you use it. Apparently, the thumbnail for this video, it shows the entire package basically occluding the whole of a perf board and only slightly smaller, I should say, than the pad around it that you would solder to. It was a nice challenge to watch him accomplish, and I look forward to more of it, which is weird. That makes you think you could do it, and it's like, wow, you're watching.
Oh, it does not.
Do it. Like, oh yeah.
Oh, it does not. Don't fool yourself. It doesn't make me think I could do it. Like I was watching these videos and trying to get tips even on how to get the enamel nice and cleanly off the end of these little magnet wires, because when I do it, it always ends up like brown and bubbly. I guess I don't have the iron up hot enough or something. I don't know. But Sprite just takes a little bit of solder, dips it in there, boom, it comes out shiny. Yeah, no, this is an amazing feat. And between this and a number of people are doing these kind of crazy live streams these days. I know Greg Davel's been doing some. Who else? Oh, I shouldn't even start name dropping, because now I know I'm missing like half of the people out there who I should be mentioning. So mea culpa. If you've got a super tiny things soldering Twitch stream going on, let us know. I'm sure we'll be interested in giving it a look.
Okay, for my next article, I want to make a sort of an unconventional pick. It's not one article, but a series of articles that Tom Nardi has started doing a Hack Chat recap series. He approached me about this a while ago, thinking, we should do this sort of, if you didn't get a chance to listen to the Hack Chat this week or participate in it, then maybe a summary of what you missed, that would be useful for people, and maybe get them to realize that, they should probably take a little bit of time out on Wednesday and try to come to the Hack Chat. And I thought that was a good idea. And I actually originally said, well, yeah, that sounds like something I should be doing. I could step up and do that. I think it ends up being better that someone else other than me does it. I book the Hack Chat, I organize it, run it, and all that stuff. So I have a different perspective on it than someone who isn't there. Normally, Tom is normally not in the Hack Chat unless it's a guest that he's particularly interested in, because he's normally recording the podcast with Elliot at about the time that the Hack Chat's going on. So having him look at the Hack Chat transcripts, look at the write-up, and maybe ask me a few questions, and then writing about the Hack Chat from the perspective of someone who wasn't actually in it, I find that to be really refreshing, and getting a different take on what transpired during the Hack Chat is very interesting. The other thing that I think is kind of cool is we can't run a Hack Chat every week. Sometimes I just plain need a break. So we take these weeks off every once in a while, and I provided Tom with a list of a bunch of my favorite chats over the last couple of years that I've been running this, and let him go back and look at the transcripts and write those back up. And it's kind of cool because it has a best of sort of flavor to it. Like, he did a write-up about when I invited Arco onto the show to talk about what his life was like at JPL, the Jet Propulsion Laboratory. He works there, and he's an engineer working on all kinds of cool things. In fact, when we had him on back in 2019, yeah, he was working on the whole deployment method for the Mars rover, that where it drops from the sky crane and all that. He was doing some testing, and he's out in the desert in Nevada or California or something like that in a helicopter, and they're lowering test loads and ballast and stuff like that from the equivalent of the sky crane mechanism, and testing it and making sure that everything was going to fire on time and all that stuff. And he was riding around, reading instruments and all that stuff, and being able to talk to him about that kind of stuff in the forum of the Hack Chat was really, really cool. And then now seeing it all over again, reminding myself, like, oh yeah, that was actually a really cool Hack Chat, and people really seem to like to talk to JPL engineers about sending stuff to space.
Dan has gotten us a number of remarkable guests. Like, we were talking about Zachary Tong at the beginning of the show. Zachary was on there. Have you ever gotten Sprite to do one?
Yes. It was a couple of times.
Sprite's done a Hack Chat. Who else? Have you ever gotten Dmitry Grinberg to do one?
That I don't think so. That might be a good one.
Have you ever gotten David Usagi Electronics to do one?
Yep. David came on.
Look at this. I mean, you got it covered.
In a lot of ways.
Listeners out there have to know that these are hackers just like you, and they're people doing interesting stuff, want to talk about it with other people who are interested in the same sort of stuff. Should everybody just start writing to you, Dan, and say, hey, I want to be on the Hack Chat?
Absolutely. I'm fine with that. And that's the thing I like to stress. I mean, yeah, a lot of times we get quote unquote stars, people who have big social media followings, people who are doing, big splashy projects, people who everybody knows, Sprite. Those are great. I love those Hack Chats because it's nice to be able to get people in touch with these people who are doing cool and impressive things that are reaching out and getting to a lot of, they've got a big reach. But that's not the point of it. Is more the cool thing that they do than who they are. And I try to, if I'm going through Hackaday IO and seeing a project, just the other day we had metal 3D printing, but electron beam metal 3D printing.
That was awesome.
Augusto Cruz, just being able to have him on to talk about his progress with the project and where he's going next and where he's been, and sharing the information with people. People who are working on projects get really good feedback. Hey, did you try this? Or maybe you should think about ... whatever. As much as we in the audience learn from whoever the host happens to be, the host probably learns as much or more from the people who are out there. And it's one of the things that I've always been amazed at with the Hack Chat, no matter how esoteric the subject matter is. And I'll sit there and I'm thinking, nobody will understand this one. For sure, somebody will show up in the chat. Yeah, somebody will show up in the chat and say, well, yeah, 30 years ago, I was doing this at, Boeing or whatever, blah, blah, blah. And you end up finding someone who is quote unquote the expert on that, and you get a lot of good feedback as a project principal. If you're trying to move your projects forward, HackChat's a really, really great way to find the people who have just that little bit of information that you maybe are lacking or whatever to move your project along. So yeah, for sure, everybody can host a Hack Chat. It doesn't have to be somebody quote unquote famous. It doesn't have to be doing something that's quote unquote important. It just needs to be cool.
My first quick hack this week is Wireshark HTTPS decryption by RL1987. This is basically a single tip for me that most of your browsers out there can be convinced to write the SSL key they're using for the transaction down by setting an SSL key log file environment variable. This lets you decrypt all of the secret transmissions going on between your browser and remote sites. You're not going to hack anything with this that you don't already have access to, but what you're going to see is everything going across the line. You don't have to man in the middle it. You can just look at it directly on your computer with Wireshark with this one simple trick. Next up, Joe Martin, tune your dish antenna like a pro. This was lovely. He basically puts a gimbal and a laser rangefinder sensor on the end of his dish antenna and figures out whether it's parabolic or not. What I thought was interesting about this is he uses, looks like it's hacker-made, Porcupine Labs interface to a Fluke laser rangefinder. This is all some pretty expensive gear. I'm surprised that we haven't been able to hack these laser measuring tapes to do our business yet, and I think that's an open and interesting challenge. Next up, Mike Molinari, web serial terminal means it's always hacking time. If you don't have a serial program on your laptop, maybe it's a Chromebook or something disabled like that, but you do have a browser, this is a piece of JavaScript that you can load in there, and using web serial, which is supported by Chrome browsers at the very least, you can then talk to serial devices in the real world. A lot of people got the wrong idea that this was about doing it over the internet. It's not. It's just running code in your browser. It can be done entirely locally. It's no problem. It's just, people like running things in browsers. Browser's the new operating system. And last up, Xtropy IR remote transforms to RF. This is a quick and simple hack, but I just thought it was sweet. It's an infrared to 433 megahertz radio to infrared bridge, and it just sits in the middle, so you can click your infrared remote at it. It ferries it around the corner by radio and then rebroadcasts it by infrared at its destination. Really sweet, very easy, and a great introduction to playing around with those 433 megahertz radio transceiver devices.
My first quick hack is Morse keyboard communicates with the blink of an eye. This is by Michael Paul Coder, and basically what this is facial recognition, looking for changes in gestures and facial position, looking for basically eyes opening and closing, and turning that into the dits and das of Morse code. I like it because, first of all, it's an added complication onto the age-old key that you would use to tap out Morse code. But it also sort of reminds me of the story about Vietnam War prisoner of war Jeremiah Denton, who got shot down over Vietnam and managed to Morse code his message of that they were being tortured by blinking his eyes. My next pick is 3D printing snap fit joints by Lucas Carollo, who has printed up some connectors that look like they would have been at home on somebody's backpack at the end of a piece of nylon strap. But the lessons learned from creating these kind of flexure mechanisms is important. Material selection is important. The exact geometry of the snaps is important. And there's kind of lessons in here for not only these specific kinds of connectors, but also snap fits that you'd use for putting together an enclosure or a case or something like that. All of these considerations of materials and geometry are kind of important for that, and this one sort of sums them up nicely. And my final quick hack pick is learn all about writing a published technical book from idea to print. Author Sarah Robinson shares not any of the technical details about what the book was about, but rather what the process of writing the book is all about. More importantly, how does an O'Reilly animal get picked? Apparently, it's a highly secretive process that the authors are not involved in at all. But finding out about the nuts and bolts of actually taking your expertise and putting it down on paper, quote unquote paper, and then getting it published on actual paper is an interesting look at another area of our field of endeavor that we don't usually probe that much.
All right, that brings us to our can't miss articles. These are long form pieces written by our fantastic Hackaday writers. And this week's fantastic Hackaday writer is you, Dan Maloney.
No.
This is the New Phone Blues, a reminder that hackers shouldn't settle. And this is the story of Dan getting a new phone and finding out that the notification app for his daughter's continuous glucose monitoring device doesn't work with it. And that is, of course, super essential household infrastructure, because if she's asleep and doesn't wake up because she doesn't hear her alarm going off, this previously would have alerted Dan and woken him up, and so he could go help her out, get her some food or something, I guess, right?
Yeah, a little snack in the middle of the night.
Yeah. But then if you get a new phone and this like critical piece of infrastructure doesn't run on it, what do you do? Dan's solution is horribly hacky. It's to keep it running on his old phone, use click send to send an SMS from the old phone to the new phone where he then receives it. You know, it's a workaround, people. But he lets him keep his old phone up and running, powered, sitting at his desk, and then he gets notified on his new phone. It doesn't have all the bells and whistles like a graph, and you can't see how the levels have been going over time, but it gets you at least the first step down. And Dan points this out in the article, and I think you're right on there. This was a quick hack. This was using parts that you had on hand, right? This was using apps that you had and phones that you had and just getting it done. And I think that's great. And your point that you kind of tried to take the standard consumer approach first, right? Like, I'm going to download this app for my phone. But when that failed to work for you, instead of getting frustrated, you then switched into hacker mode, which is, all right, I can do this. I don't know how I can do this yet. I'm going to put all my tools together and figure out a way to do this. And lo and behold, you do. Is it the best way? No. Is it probably your end game way? I'm guessing it isn't, but I'm going to ask you that as a question in about 10 seconds. But it is definitely a workable way. So where are you at now?
First thing, I want to dispel the notion that I did this instead of getting frustrated. Oh, no. I did this after getting frustrated. And there was a lot of angst about this because we had just gone through this whole big rigmarole of changing phones over and stepping up into the 21st century instead of, pay-as-you-go phones, which I've been nursing along for years because I'm a cheap bastard. And instead of actually paying for a contract, we finally said, okay, fine, let's do it. Let's go get some actual real phones. So we go through the whole thing and we configure the phones to our liking and all that. Now, this probably should have been the first step, and it probably should have been some due diligence beforehand to see if it actually runs. So, my bad. But then we find out that this app doesn't run, and we're like, oh, now we got to do the whole damn thing all over again. I was sitting at dinner with my wife, and I was just griping about this whole thing and, throwing my hands up. Oh, that's it. We got to go get new phones, blah, 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 blah. And I literally looked at her and I said, wait a second. This isn't me. This isn't what I do. I'm not going to sit down and take, what's handed out to me in terms of technical solutions. I'm going to take what I have and I'm going to make it into something that works. And I came up with a couple ideas off the top of my head while I was at dinner that didn't pan out. Like, I was going to just get an SMS only SIM card because I thought they existed. So I kind of racked my brain and I came up with this solution. And like you said, it is not optimal. I know it's not optimal. It's aggressively non-optimal. And I don't want it to be this way forever, but it gets me through to the next thing. What's the next thing? I'm not sure. There's what I would really like to do, and this is a long-standing project of mine that I've wanted to do ever since we had a run-in with the vendor, the CGM vendor's service going down. Their cloud service went down for a couple of hours, I think it was. It wasn't days. It was a while, but the connection between her equipment and our phones goes through this cloud service, and when their servers are down, we're done. She'll get alarms locally on her insulin pump, But that fact won't be relayed to us. And I believe we even had a problem when this actually happened where she went low overnight and we had no notification of it because of the lack of cloud service. Luckily, I managed to hear the alarm from her room, so I was able to go and respond. But it was confusing, well, why isn't this working, And it was nothing that we were doing wrong. It's just that the service was gone, and that led me to, to the conclusion, like, well, I don't know if I can count on that. I need to cut out the middleman here if it's possible. And so I came up with this idea that I would find a way to receive the signals that were coming off of her continuous glucose monitor. I built some sort of little hardware or something, some sort of little box with Arduinos and SDR or something. I don't know. Unfortunately, they quickly deprecated the sensor that she was using and went with something else. The thing that I had the most information on was no longer the thing we used.
Oh, they're one step ahead of you.
Yeah, exactly. And now we this present situation kind of reiterates that need that there should be something that gets rid of the middleman, and there should be a way for us to monitor her more directly. So that's kind of where I am now. I did get a lot of useful comments, in the reader comments that pointed me in the right direction for how to integrate this CGM system. There turns out to be some open source projects that have hacked the signal a little bit. There's some stuff I can download, where the work is already done for me. And I'm all about that. I don't, if I don't have to sit down with an SDR and an oscilloscope and look at signals, I like doing that kind of stuff. But if that work's already been done for me, okay, I'll take it. So that's kind of where I am now with that. And I do appreciate the comments and the support that I got in the response for the article. So.
Well, that about wraps it up for the podcast this week. If you'd like to reach out to us, you can, editor@hackaday.com. If you want to check out the show notes full of all of our fantastic links, that's at hackaday.com/podcast. We love to get tips at the tips line, tips@hackaday.com. And until next week,
keep on hacking. Not my finest moment.
Yes, please.
Okay.
Then we're set. Relax and enjoy.
Wow, what a delay. It's like half the planet,
That sounds like a horrible idea.
And of course, this is not to say that I did not repeat this stunt many years later when I had children with a 2-liter soda bottle.